All right, so a parabola, so we've done these before. The actual definition is a set of all points in a plane that are the same distance from a given point called the focus and a given line called the directrix. What we need to know about these two things is that the focus is always going to sit inside of the parabola. So the focus will always be inside of it, kind of like a bowl holding something. That focus will always be on the inside, and the directrix is just, it's a dashed line, so it's not actually, you don't actually draw it on the graph, but it is a dashed line. It's, if you go from the focus to some point on your parabola, and you go from that parabola down to your directrix, those two distances would be the same. Okay? No matter what point you end up doing, the distance from the focus to the parabola and the parabola to the directrix is always the same. That's the relationship. It's, yeah, you're right. It doesn't look like it is, but it is. This is me trying to make something in Word. Well, tough. Okay? So that's a technical definition of it. Does anyone remember what the standard form was for our parabolas? It was y equals a. What did the a tell us? If it opened what? Up or down. And then we had an x minus h squared plus k. Does that look familiar? No. It should look familiar. We did a whole unit on it at the start of second semester.
That's why I don't remember that.
Okay.
Miss Burns, I don't remember what I had for lunch.
Well,
It was like 10 minutes ago.
so the A told us if it opened, remember? The A told us if we opened up or if we opened down. How do we know if it opens up? What type of number would the A be?
Positive.
Positive, and if it opens down, it would be negative. And then where's the vertex? At the HK. HK was the vertex. Okay? So we used this earlier to say the vertex. We knew if it opened up or down, and then we made an XY chart, and we plotted a few points to get the idea of what it looked like. We're actually not going to plot, we're not going to do XY charts. There are going to be two other ways we can graph it. Okay? But we're also not only opening up and down. We are also going to open right or left. Okay, so if we open up or down, our y is going to be alone. If we open up left and right, it's going to be the x alone. But otherwise, it's the same formula. A, instead of x minus h, it would say y minus k squared plus h. But the vertex is still hk. The A still tells you which way it opens. And because the x is alone, you know it opens left to right. And when the y is alone, you know it's going to open up or down. Okay. So we're going to add on to it because we're not only going to open up or down, we are also going to open up left or right. But the formulas really work the same. Your vertex is still hk. The A is still telling you how it opens. We're just going to need to find out a few other things about this. So how we're going to graph this is we are going to find the vertex. And on the diagram here, this is where the vertex would be. All right, so that would be the vertex. So that's going to be the first thing we do when we have it in standard. We're going to find the vertex. And then we're going to find the focus and the directrix. The focus here, that distance, it's a distance of 1 over 4a. So we're going to figure out what that distance is, and we're going to add it onto our vertex. And that will give us where the focus is. And so we'll plot the vertex. We'll figure out this distance. We'll plot the focus. And then the third thing we plot is at the focus, we're going to find something called the LR, which tells us how wide our parabola is. So at the focus, we're going to graph this little line here. That green's kind of hard to read. I'll change it to a darker. So we're going to graph a line here, which tells us how wide it is, which is our LR, which is the absolute value of 1 over A. So if we have an A value of 1, we know that our width at our focus is 1. And then you're just going to graph your vertex and connect it to the ends of those lines. And that's how you're going to graph your parabola. Okay. So we'll do some like it. Don't worry, we'll do a few like that. So the next slide is actually going to be a chart of how we go about finding the focus and the directrix and the LR. That'll have everything together. Now this chart that's on the next slide has all the formulas on there for you and all the equations. You can find it online. If you just search underneath, it'll say like Unit 10 notes. They should be uploaded already underneath my name. So if you want to just print off the chart, that'd be a good idea. There's one for each conic section, a chart for each shape. So you might want to print a sheet off that has all that information on. So you might want to print it off. Okay, but this is a summary of what we just talked about, but it gives us more specific formulas. Okay. So standard form, we just wrote down. Standard form we have here, we have y equals a times x minus h squared plus k. We just wrote that down. Okay. If that's the case, our vertex is at hk, and our axis of symmetry is at x equals h. That was the information that we had already known. Okay, that was stuff that we had already known from our previous unit. Now here, the focus and the directrix. If you take a look, on the previous slide we had talked about that distance of 1 over 4a away. So that's what this is telling us. So our focus here is at h, and then k plus 1 over 4a. So we have to go a distance of 1 over 4a away. So we'd add that number on. And the directrix, we would subtract that number. So these two, this just represents a distance of 1 over 4a away from the vertex. Okay, it's just that distance away. And then we already talked about the direction of opening. If we're greater than 0, it's up. If it's less than 0, it's down. And then this LR length, it's the lattice rectum is what it's called. And it's just the absolute value of 1 over a. So whatever number you have out here, you just have to take 1 divided by it. So if you have 2 out in front, 1 divided by 2 is a half. So the length at the focus is a half. And then the other standard form, which I think you guys already also wrote down, x equals a times y minus k squared plus h. So in the x's alone, we're opening up left and right. Vertex is still at hk. Our axis of symmetry here is y equals k. Now what I want you to notice is that in the parentheses, here the y is attached with the k, and look at your vertex, the k is in the y position. All right, so whatever number or whatever letter is in here, so this is a y minus k, that's going to tell you your y value of your vertex. Here, this one had x minus h, so that's going to tell you the x value of your vertex, your h. And then the focus and the directrix, these also are 1 over 4a away. Except for since we're opening left and right, we are adding it and subtracting it to our x slot, our h. Because our focus and our directrix now will either be left or right. And then it's going to open right if we're greater than 0 and left if we're less than 0. And the LR is still 1 over a. Okay, so we're just going to jump in and try an example. And the first part of this, when we find the vertex axis of symmetry, that's review. Okay, and so it's finding the new things, the 1 over 4a and the LR. So from this equation that's given, we want to find the standard form, the vertex, the axis of symmetry, the focus, directrix, which way it opens the LR, and then we want to graph it. So our first equation here is y equals negative, and then in parentheses, x plus 1 squared plus 4. So this is already in standard form. Okay, so we have to decide if this is an x equals or a y equals first off. It's y equals. So since this is y equals, we're going to go down and we're going to follow our y equals chart to help us find the information. So this is already standard. So from here, we should be able to just say what the vertex is. So what would be the vertex from the equation negative and then x plus 1 squared plus 4? What would be our vertex from that equation? Not 1, 4. It's negative 1, 4. Remember, because our standard form has x minus h, so in the parentheses we want to think about taking the opposite sign. So that's our vertex. The axis of symmetry then here says x equals h. So what would our axis of symmetry be? X equals negative 1. Our h is negative 1. So if this said x minus 1 squared, then it would be a positive 1 for the vertex. Yep, you're always going to kind of flip that side. Which way will this open? Will this open up or will this open down?
Down. It's negative.
Okay, so this we know is going to open down. Okay. So that would have been the information that we've already learned from a previous unit. Okay? So now we're going to add on the new stuff. So we're going to find the focus and the directrix. In order to find the focus and the directrix, we need to figure out what 1 over 4a is.
Where do you get the 1 at the a at?
Well, where's the a in the standard form?
Front, so it's negative 1.
Okay, so the a is negative 1 here. So 1 over 4 times negative 1 is?
1 over negative 4.
Okay. So a fourth is our distance away. All right, so since this is opening down, our vertex would be right there at the top. The focus would be inside of it. So would I want to add a fourth onto the vertex, or would I want to subtract it?
Subtract.
I'd want to subtract it. And that's also what this negative sign is telling us here, that we're going to subtract it from it. So to get to the focus, I'm going to look at my vertex. My negative 1 will stay the same, so I'm just moving in the y direction. So if I subtract a fourth from 4, what do I have? 4 minus 1/4. Yeah, 3 3/4. Okay, so it's my focus. 4 minus 1/4 is 3 3/4. 4 minus the fourth is 3 3/4.
Keep the h.
Yep, we keep the h because the k is what's moving. The y values is what's changing here. So then the directrix says y equals. So y equals. If we subtracted a fourth to get to the focus, the directrix is on the other side, so we would add a fourth to get to the directrix. So what would be 4 plus a fourth? 4 and a fourth is at the directrix.
So this whole unit is all going to be like fractions?
We'll see some, yeah. You can handle it. I mean, it's just adding and subtracting a fourth, or those should be pretty easy fractions. The LR then is the absolute value of 1 over a. So our a value is negative 1. So what will be the absolute value of 1 over negative 1? 1. So the LR here is 1. So now we're going to graph it. So we're going to start with our vertex at negative 1, 4. Now we are going to approximate about a fourth of the way down to get the focus. Okay? So you're going to have to look and you're going to have to do your best job approximating. So here's the vertex. I know my focus is beneath it, about a fourth of the way down, so I'm going to put a dot right beneath it for my focus.
So close.
Yeah, they should be pretty close to each other. Okay, so this one's the vertex, there's the focus. Then the length at the focus is a total distance of 1. How do we know what a total distance of 1 is? It's not 1 in both directions, it's a total of 1. So we want a total distance of 1, so a total of like one of these boxes. So we could go halfway across to halfway across. That would give us a total distance of 1. And so then you just need to connect your vertex to the ends of that little line you drew. And there's your parabola with no XY chart needed.
You don't have to label anything else.
Nope, you could certainly put your axis of symmetry on there. You could put your directrix on there, but they're not needed. First example, okay? Okay, so now, next example, it's not going to be in vertex form for us. So we're going to have to put it in vertex form, so we have to remember how to do that, which we did do at one point in time. So same directions. This is not already in standard form. Y equals 3x squared plus 24x plus 50. I'll take your phone.
It's burned.
Jordan, you've been on it. I feel like maybe, Gabe, I should just take yours too while I'm at it. You haven't used it, but... All right, so this does not look like standard form. So first we have to decide, is our standard form for this, will we have our y alone, or would we have our x alone?
Our y alone.
Our y alone. We know that because the y is not squared here. Okay? So that means to get this in standard form, we want it to be y equals a times x minus h squared plus k. We've done this before. We've rewritten these like this. You just have to refresh your memory as to how it was done. Some of you never really knew it in the first place, so I would suggest you pay attention this time around. Okay? There's a few of you in here. All right. So first off, is there a number attached to the x in this parentheses?
Yes, 3.
But in the standard form, is there? No. So currently, what do we have attached to the x? 3. So we should take that 3 out first. So we're going to take the 3 out. So if we take 3 out of 3x squared, we have x squared. What if we take it out of 24? 8x. We are not going to take it out of 50. Instead, we're going to leave the plus 50 at the end. Is this starting to look familiar? What's this process called that we're doing?
Elimination.
Not elimination. Although it was a nice dance to go with it. Anyone remember what this is called?
Yeah, what does it start with?
It starts with a C,
Congruency.
and there's 3 words to it. Completing is the first word. Completing the square, yeah.
That's what I was going to say.
Completing the square. So we have to complete the square here. So how do we figure out what that number has to be? What did we do?
You have to do the x plus 4.
Good. We have to divide this by 2 and square it. So we divide this by 2 to get 4. We square it to get 16. Now if we add 16 here, we want to keep our equation the same.
You have to minus it to the other side.
Minus 16 to the end. But not only that, what number did we take out of the parentheses? 3. So what number should I multiply this by?
3.
3.
So it's actually like a Jill.
How come you just times 8 by 2?
No, we did 8 divided by 2 to get 4. 4 squared is 16.
Oh, I get it.
Okay, so now we have y equals 3.
X.
And now we completed the square, but what goes in the parentheses here? X plus what? Good, x plus 4 squared. And then we have 50 minus 16 times 3. Well, what's 16 times 3?
6, 12, 18.
48. We times by 3 because there's a 3 in front of this parentheses as well. So 50 minus 48 is?
-2.
Try positive 2. So there's our standard form.
Now we can graph it.
Now we can say everything else we need to say about it. So,
That was a lot of work. Can you be done?
no. Vertex.
You uncoil.
Where's the vertex?
The vertex is HK. It's HK, so K is at the end, H is right there.
So what are the two numbers for it? Negative 4, 2. Axis. X equals H. So what would that be for this one? Yep, X equals negative 4. You probably want to pay attention instead of talking across the room. Okay? Which way will this open? Up? Okay, so now we need to figure out what the focus and the directrix is.
It's supposed to go down.
It's positive 3, so it's going to go up.
That's not in my notes.
Okay. So we need to figure out what the focus and directrix is. So we have to figure out what 1 over 4a is equal to. So what's our a value?
3.
3. So 1 over 4 times 3 is what? 1/12. Okay? So we decided that this opens up. So here this is opening up. Your vertex would be at the bottom and the focus would be inside.
The focus is 1/12.
So the focus is 1/12 away.
Barely away.
Yep, it's very, very close. So to get to the focus, would we want to add or subtract? We're going to want to add because, see, we're above the vertex here. So take your vertex. We're going to add it to the 2. So 2 plus 1/12.
Is 2 and 1/12.
Yep, 2 and 1/12.
So negative.
To get the directrix, you will subtract it from 2. So 2 minus 1/12.
Is 1.
Yep, 1 and 11/12.
What do we do there? There's a 12th in each full number.
Yes. If your denominator is 12, and you want to subtract 1/12, you would have 11/12 left over from a whole number. Then you would have,
2/3.
correct. Yes, Lauren.
I learned
Okay,
more in this class.
How do you know what side of that chart thing to use?
Well, here the y is alone, so we would be using the y equals. Because the x is being squared here. Okay, our next example will be the other way around.
So is this just one way of doing it?
Yes.
So I think I'll stick to the XY chart.
Well, you are going to have to answer all of these for, I mean, this is going to be a quiz question and a test question, so.
Will you give us those
Yeah, you'll have those formulas. Okay. Now we need to know what the LR is. So that's absolute value of 1 over A. Your A here is 3, so the absolute value of 1 over 3 is a third. Okay. So we need to graph it. So where will we start for graphing this?
You will start with the vertex.
Okay. So we're going to start with negative 4, 2. Now, 1 over 4a was 1/12. So if we want to go 1/12 away,
It's like just there.
yeah. There's the vertex. We just have to go up just a little bit.
And then you have to do one whole.
There's our focus. Now, what will be the length at the focus? The length at the focus will be your 1/3. So we need a total distance of 1/3. So it's like a third of a box here. So if you look at this and you go a third of a box is, I don't know, like that big.
So it's babies.
So just kind of center it on there and draw it.
It's little babies.
Where's what? Focus is just above the vertex. It's 1/12 away. So we just went up just a little tiny bit and put the focus. And then to graph it, you'll go from the vertex to the edge of your 2 LR's lengths that you just drew.
You're done.
And we graphed.
That's 1 plus, that's a 5 on your worksheet right there.
Okay, we're going to do one more together. So we have to see what happens if we open up left and right. So this equation, x plus y squared equals 4y minus 1.
Okay, so you gotta subtract y squared over.
Okay, so we're going to have to subtract the y squared over first. So our x is alone, so we know that this will be going left or right. So the equation will be x equals a times y minus k squared plus h. Correct. X equals goes left and right. Y equals goes up and down. Think about your x and your y axis. Your x axis is horizontal, so it'll go left and right. Your y axis is vertical, so it'll go up and down. Right, only one of these would be squared. So notice here, only the y is squared, so we'll get the x alone. Now, we can't have a number attached, so what should we do with this minus 1 here? Take it out. So if we take the negative 1 out, we have y squared, and then what? Minus 4y. Leave the minus 1 at the very end. Okay, so now we have to complete the square. So what do we have to do with this 4? Divide by 2 first, and then square it. So 4 divided by 2 is 2, and 2 squared is 4. Okay, so minus 4 and times it by what number?
By
Our negative 1.
4, and then that's 3, and then you're like, wow.
Okay, so x equals negative 1 times
Y squared.
y minus what? Yep, y minus 2 squared plus 3. So there's standard. Okay, so HK. So our vertex is at HK. So what will be the vertex for this one? Yep, good. The vertex will be 3, 2. Our axis will be y equals k. So what will our y equal here for our axis of symmetry if it's y equals k? Yep, y equals 2. And which way will this open? Not? down, this will open left.
I still don't understand that.
It opens left because this is negative and we have our x alone. X alone means we're opening up left or right.
That way?
It's going that way.
That's not right.
Okay.
It's open left because why?
The a is negative and the x is alone.
Okay.
Okay, so now we need to find the 1 over 4a in order to figure out where our focus and directrix is. So what's our a value here?
-1.
-1. So 1 over 4 times -1, what will that give you? -1/4. Now let's think about this. We're opening left. So there's the vertex. The focus should be inside. So to get to the focus from the vertex, we will subtract the 1/4.
In order to what?
In order to get from the vertex to the focus, we'd have to subtract because it's to the left of it. From your from your vertex. Yep, so 3 minus 1/4 would be what? 2 3/4. Your y value would stay the same. Directrix. Directrix would be x equals, because that's the value we're changing. We're changing the x here. So we'd want to add 1/4 onto our 3. So 3 1/4, yep. And the length of our LR is the absolute value of 1 over a. Our a is -1, so what's the absolute value of 1 over -1? 1. So now we'll graph it. So we'll start at the vertex, which is at 3, 2. And then how far over will I go to get to the focus? I'll go 1/4 to the left. Okay, so there's my focus. And then what's going to be the length that I draw here? A total of 1. So how are we going to get a total of 1? Go about halfway, both of them? So about there?
A little more on top there.
So we'll go from the vertex to the edge of those lines. I missed the edge of that line.
Oh, jeez Louise, now we're starting.
There we go. So there's our parabola.
I didn't say it was golden.
All right.